As you watched in your previous video, the triangle inequality theorem states that the sum of any two of the sides must be greater than the third side to actually form a triangle. So if we were to look at this algebraically, a plus b has to be greater than the length of c. B plus c has to be greater than a, and a plus c's, the sum of a plus c must be greater than b. Okay, so, but how do we determine the range of a third side if you're only giving two of the sides? Well, let's say I have 2 and 11, and I need to know what range of numbers the length of my third side could be. If I was to label these A, B, and C, and I could label them A, C, and B, it honestly doesn't matter because it has to be true for all three of these scenarios. So if I did 2 plus 11, that has to be greater than C. So therefore, 2 plus 11 is 13. So C would have to be greater than 13. Now, on the flip side, I used A and B. So then let's see, B plus C. So 11 plus C has to be greater than A, which is 2. And then my third option, so this is 1, 2, and 3. 1, 2, 3. Then A, 2 plus my unknown value would have to be greater than 11. Now, if you notice, if I subtract 11 from 2, I'm going to get a negative number. And obviously, we cannot possibly have a negative length. So we can rule out option 2. So looking at option 3, if I subtract 2 from both sides, C has to be greater than, and 11 minus 2 is 9. So my sum, or I should say my range, would have to be between 9 and 13 to fulfill our inequality theorem. And we would write this as C has to be less than 13 but greater than 9. Okay, now that's the algebra approach and essentially explains mathematically how we get the range from 9 through 13. But essentially all I did was add my two sides and subtract my two sides to get my range. So although I took the time to show you how it applies algebraically to the theorem itself, essentially the shortcut is all you have to do is add the two sides. 2 plus 11 gives me 13, and then just take the difference of the two sides, which of course is 9, and that is your range. And just keep in mind, you can never have it equal to. So that is why I specifically used the less than signs and not the less than or greater to signs.